Welcome to This Explainer. Today, we're jumping right into something absolutely fascinating. We're going to look at the very fundamentals of scientific inquiry to understand exactly how our world works. We encounter so many amazing things every single day, and honestly, it's super easy to just walk right past them without a second thought. But today, we're going to slow down a bit. We're going to look at the evidence and uncover the basic building blocks of how we actually study our environment. So get ready to shift your perspective on what science really is, because I promise you it's a whole lot more than you might think.
Have you ever wondered why plants bend towards sunlight? Just ponder that everyday mystery for a second. Imagine you're a Basic 4 learner sitting in a classroom in Ghana, and you look over at a plant growing near the window. You notice it's completely leaning towards the glass, just stretching out for the light. It's a completely normal, relatable observation, right? But asking why that happens? That is the exact spark that sets off the entire engine of human discovery. You definitely don't need a PhD to ask that question. You literally just need to look at the world around you and wonder.
Section 1. The Spark of Curiosity.
You see, noticing those little details like a plant reaching for the sun or even just ice melting when it's left outside isn't just daydreaming. It is the absolute foundation of how we study living things, non-living things, materials, energy, basically our entire environment. Fundamentally, science begins with curiosity. Long before you ever crack open a textbook, you start with what you can actually see, touch, hear, or measure. Our basic human senses, those are our very first tools for gathering evidence. When a learner notices that ice turns into water sitting in the warm sun, that is careful thinking in action. Science is not some distant, unapproachable concept. It's right at our fingertips. It's all about getting hands-on with our environment and using our natural curiosity to drive problem solving. So the word science actually comes from a Latin word that simply means knowledge. But in practice, it's the study of our environment through observation, questioning, and investigation. And that's the key right there. By actively observing, questioning, and investigating, we take a static word like knowledge, and we transform it into a dynamic, active pursuit. It's an ongoing action. It's what helps us gather real information and make sense of the world around us in a highly tangible way.
Section 2. Defining science.
There's this huge misconception out there about how we actually pursue this knowledge. A lot of learners, and let's be honest, adults too, kind of think science only happens in sterile laboratories by people memorizing giant lists of complex facts. They think it's just about reading a book and knowing the answers without ever testing them out. But the reality? It's totally different. Science uses familiar, everyday objects you find right at home or at school to investigate and question. It's not about passive memorization. It is an active reality. When a parent encourages their kid to ask why and how about things right in the middle of their living room, that is real science happening in real time.
Section 3. How scientists think.
Okay, so if science isn't just memorizing facts, what does the actual process look like? Well, let's open up the toolkit. Here is the absolute core of scientific thinking, broken down into 4 distinct steps. First, you observe carefully. You use those senses we talked about to notice something in your environment. Second, you ask questions about what you just observed. Third, and this one is absolutely massive, you investigate and look for evidence. Now, why is this third step so crucial? Because it's always better to investigate before you just blindly accept an explanation. Hard evidence is what actually separates a random guess from real knowledge. And finally, step 4, you draw conclusions based on the evidence you gathered. This right here is the exact mental framework that empowers us to solve complex problems. So going back to our plant question from earlier about why they bend toward the light, we don't just guess the answer, right? We test the idea directly. You place one plant in the sunlight, and you put another plant in total darkness. By changing just one single thing, the light, you are actively hunting for hard evidence to see exactly how the plant reacts. You're moving from a simple observation straight into experimentation. And that is how we truly confirm our ideas about the natural world.
Section 4, Science in Daily Life. Now you might be thinking, okay, testing a houseplant is cool and all, but what does this mean for the real world? Well, these exact same steps are actively used by professionals everywhere to solve massive real-life problems in our communities every single day. Doctors and nurses don't just guess if you have a fever, they use scientific tools like thermometers to gather evidence and treat diseases. Farmers don't just throw seeds anywhere and hope for the best. They literally test different soils to find hard evidence on which one grows maize the best, which improves crop production for all of us. Engineers rely on scientific principles to build safe bridges, machines, and the houses we live in.
All of these professionals are essentially doing the exact same thing as our simple plant experiment, just on a much larger scale that improves our infrastructure, our food supply, and our health.
I mean, just think about the sheer scale of this for a second. Hospitals, farms, schools, homes, factories, transport systems, communication devices. Science is a crucial, unavoidable tool that we use literally everywhere. It isn't just confined to a single 45-minute subject in a classroom. It is the underlying operating system of our entire modern society. From the device you're using to watch this explainer right now, to the transport system you take to get to work or school, science is right there, helping us make better decisions and fundamentally improving our lives.
Which brings up a really fantastic takeaway straight from the curriculum. Use real-life examples to make science practical and meaningful. Science is deeply practical, and I highly encourage you to take this to heart. Go out and actually interview a health worker or a farmer or maybe a mechanic in your own community. Ask them how they use science and observation in their daily work. I guarantee you will be amazed to see these exact principles, observing, questioning, investigating, and drawing conclusions in action right in your own neighborhood. So to wrap up this explainer, I'm throwing the ball entirely into your court. I challenge you to observe one single object in your environment right now. It could be your coffee cup, the window pane, a pet, or even your phone. What scientific questions can you ask about it? How does it work? Why is it made out of that specific material? Remember, it all begins with curiosity. Your environment is just waiting to be investigated, so what will you discover today?